In today's episode of Daily AI Brief, we dive into the latest advancements and emerging risks in artificial intelligence. With NVIDIA's new Nemotron 3.5 lighting up the hardware scene and the growing concerns over sleeper agents in large language models, today's tech landscape is as exciting as it is challenging. Let's dig in. NVIDIA has announced a significant leap in deep learning model efficiency with its release of the Nemotron 3.5 Lightning NVFP4 model. Designed to optimize AI applications in resource-constrained environments, this model leverages advanced quantization techniques to maintain high performance while shrinking size and increasing throughput. One of the key innovations in this model is the use of quantization-aware distillation. In GWAD, a full-precision teacher model guides a quantized student model through training, using Kullback-Leibler divergence loss to recover accuracy often lost in quantization. This technique allows the model to maintain near BF16 accuracy without needing the entire training dataset in its deployment phase, streamlining efforts and increasing efficiency. The model also integrates post-training quantization, PTQ, a strategy that fine-tunes the pre-trained quantized models, further enhancing deployment efficiency without the necessity of full retraining cycles. Among the technical breakthroughs, the NVFP4 format is notable. The model supports 4-bit floating point representation, providing increased throughput and reduced memory while enhancing performance on NVIDIA's Blackwell GPUs. Another technical highlight includes a multi-stage post-training pipeline. This pipeline combines supervised fine-tuning and reinforcement learning, employing adaptive block scaling to dynamically adjust resource allocation, significantly improving real-time processing capabilities vital for enterprise applications. The introduction of the Nemotron 3.5 comes with impressive metrics that underscore its capabilities. There is a substantial model size reduction from 1.1 TB to 331 GB, which translates to an impressive 3.3 decrease in size. The throughput has been increased by an astonishing 4 times compared to previous NVIDIA models, facilitating more operations per second and thereby optimizing processes. Moreover, the time taken for quantization through Megatron LM has been drastically reduced to only 45 minutes, compared to the 120 minutes needed by traditional methods using Hugging Face transformers. Despite the notable advancements, several trade-offs must be considered. For instance, the generalization of QAD across diverse architectures remains to be fully validated, posing a potential challenge in terms of its broader applicability. Moreover, the long-term stability of models quantized with the NVFP4 format in high-load production settings has not been fully tested, stirring some uncertainty about long-term deployment. For those interested in exploring these cutting-edge developments, NVIDIA offers comprehensive documentation on implementing post-training quantization for Nemotron models. Practitioners are encouraged to experiment with the QAD technique on sample datasets or utilize NVIDIA's Model Optimizer APIs to deploy pre-trained models efficiently. Ultimately, the Nemotron 3.5 represents a significant stride forward in AI efficiency. It sets a high benchmark for resource-optimized computing and holds the promise of enabling more complex real-time applications, paving the way for advancements in mobile and edge computing. A recent study has spotlighted a critical security risk in large language models, sleeper agents. This vulnerability concerns the susceptibility of LLMs to malicious fine-tuning, which could embed triggers causing models to behave harmfully under certain conditions. The research involved replicating 2,200 papers from the International Conference on Machine Learning, ICML, emphasizing how open-weight models might hide triggers that only manifest under specific prompts. The study's findings highlight the need for heightened security measures in deploying these models, given the potential for exploitation by malicious actors. 1. Safety Guidance Trigger Method. This method focuses on optimizing safety triggers and aligning model features with safety representations. The two-stage process includes refining a safety trigger, essentially a set of input conditions that guide the model away from harmful behavior, and ensuring the model's internal features reflect these safety considerations. Microsoft's detection technique. This involves a scanning approach specifically designed to identify sleeper agents by detecting maliciously implanted triggers within models. Microsoft's method underscores an industry shift towards preemptive detection measures in AI deployment. 3. Parameter efficient fine tuning, PEF, a framework used to inject sleeper agent capabilities into models. PEF emphasizes minimal parameter changes to achieve specific behavioral outcomes, allowing hidden triggers to persist while models operate normally otherwise. 4. Semantic drift analysis. As a detection technique, this method scrutinizes how model outputs change in response to various inputs, flagging potential backdoors without altering model architecture. Practical steps. Utilize Microsoft's scanning method. By incorporating key phrases into testing frameworks, organizations can proactively identify sleeper agents in open-weight LLMs. Integrate safety guidance triggers. Embedding these into model training can help preemptively counteract potential malicious fine-tuning efforts. Experiment with semantic drift analysis. Conduct practical experiments across diverse LLM architectures to assess the viability of this detection method. Trade-offs and challenges. Validation across models. Current detection techniques need extensive validation across different architecture types to ensure universal applicability and reliability. Real-time deployment impact. Implementing these detection methods may affect the operational dynamics of real-time system deployments, calling for a careful balance between security and performance efficiency. Implications and outlook. The study highlights an urgent necessity for robust protocols to safeguard against the malicious manipulation of AI models. It suggests that organizations and regulatory bodies may need to establish stricter standards and guidelines governing the deployment of LLMs. Moreover, as AI continues to integrate more deeply into various applications, ongoing research and adaptive countermeasures will be critical in mitigating evolving threats. This direction not only bolsters AI security, but also reinforces ethical practices in machine learning model development, a priority as these technologies become more pervasive in everyday contexts. As we wrap up today's episode, the developments from NVIDIA and the research on LLM sleeper agents showcase the dual nature of progress in AI. While innovation drives efficiency, it also demands rigorous attention to security. Stay curious and vigilant in your AI endeavors.